Okay, now we'll talk about points called extreme values or extrema. And these are maximuses and mins. Okay, so we have two types. We have relative extrema or local. And these are max or mins, maximum or minimums on a graph. So this is any high or low point on a curve. So you're looking like for hills and valleys. So this is any high or low point. The absolute extrema it's the absolute highest or lowest point on the curve. And there's only one each of those if there's any. Okay, so we have local and we have absolute. So if we look at a graph like this, let's decide what our points are. So look for any high or low points. So here's a high, here's a low, here's a low, here's a high, here's a low, here's a high. And this right here would be a local min. It's not absolutely the lowest point on the curve. The absolute min, this is a low point, would be right here at the end point. That's absolutely the lowest this curve goes. This is a local min, and this is a local min. So those are valleys. Here's a max, here's a high point, a max, and here's a high point, a max. So these are all local maximum points. So those are the hills on top of a hill or a mountain. Alright, there's no absolute max here. Now I know you might think that this point right here might be an absolute max, but it's not. There's no absolute maximum because of this, the fact that this graph goes to infinity and infinity. So this graph right here goes past this point. So this graph is going to infinity, so there's no absolute highest point on the graph. There's some high points, but there's no highest point. So you have to be careful when looking for your absolute extrema. Now, another thing you have to be careful of is when it asks for the value, when you see that word value, it's asking for the y value. Not the x value or the function value. When you plug it into the function, it's the number you get, which is the y value. So be careful about that. That word value means y value. Okay. Now these points can occur three places. At the points where you have a horizontal tangent line, that's where y prime equals 0. Where you have sharp points, this is where you have a vertical tangent line. Or where y prime is undefined. And why do we have derivatives involved in here? Because remember, y prime is the slope of the tangent line. When the slope is 0, you have a horizontal line. So the slope of the tangent line is 0. Or the slope is undefined. That gives you a vertical line, where the slope of a line, where you have a vertical line, the slope is undefined. Remember, y prime determines the slope of the tangent line, and where your slope is undefined, you have a vertical line. Or you can have the max and mins at the endpoints if you have a closed interval. So these are the three places you're going to look for these max and min points. Okay, so again, let's go over that. Number one, the first thing you should do is note if the problem has endpoints. These must be checked if it does, because there could be a high or low point. Then you find where the derivative is 0 or f prime is undefined. Here you have horizontal tangent lines. Here you have vertical tangent lines or sharp points. Maybe you have to check around that. And then you check to see if you actually have a max or a min. Okay, so let's do an example. Actually, before I do that, I need to go back up here. These points are called critical points. They're possible max and min points, but you have to check that. So where f prime is equal to 0 or f prime is undefined is a max or a min point. Okay. First problem, f of x is x cubed minus 9x squared plus 24x minus 10. There's no endpoint. See, that's the first thing you should check. So we go right to taking the derivative. Factor out of 3. Factor. And these are called critical points. Now, there's going to be a way to determine whether these are maxes or mins. And that's going to happen later. We'll decide that later. But these are the critical points. And you have to decide if they're maxes or mins. So in this section, what they want you to do is just kind of graph it. And we know an x cubed function looks like this. So 2 and 4. 2 will be the max, and that's going to be a local max. And 4 is going to be where the local min are if you graphed it on your calculator. So f of 2 is going to be 8 minus 36 plus 48 minus 10 is 10. And f of 4 is going to be 64 minus 144 plus that's going to be 6. So 210 is the max point and 46 is the local min. The extreme values, the maximum value is 10 and the minimum value is 6. So if they ask you for the word value, remember they're asking you for a y value. Let's try another one on an interval. Here we have 2x cubed minus 15x squared plus 24x plus 7 on the interval 0, 6. So these have endpoints, so we're going to have to check our endpoints too. So the first thing we're going to do is take the derivative, but keep in mind we got to check the endpoints. We can factor out a 2 here, I think. Let's see, that's going to be, let's try 2x and 2x, 4. Try 3 and 4. 6 and 2. That's not going to work. Let's try 4x and x and 3 and 4. That's not going to work. Let's try 2 and 6. Let's see. I did the derivative wrong. Let's go back. Sorry about that. That happens. Okay. That's 6x squared, sorry. Factor out a 6. See, these should be easy to factor. That's how I knew I made a mistake. So my critical points are 1 and 5. Now, to find your maxes and mins, what you do is you plug in your values. So y of 0 and y of 6, we're going to check the endpoints. And then you check 1 and 5, your critical points. And make sure that these are both in your interval. These are both in our case. If they're not in the interval, then you don't check them. Okay, they have to be between 0 and 6. So that's the important thing. So make sure that you check that. If one of them isn't, then you just get rid of it. It can't be a max or min because it's not in the interval you want. So if you plug in 0, we get 7, so that's 0.07. Okay, we plug in 6. We get 43. So 6 and 43. We plug in 1. We get 2 minus 15 plus 24 plus 7. 18, so we get the 0.1, 18, and we plug in 5, we get 2. So this is going to be our minimum. We look at these values here and see which is the smallest and which is the largest. This is going to be our absolute minimum value. And 43 is the largest. That's going to be our absolute maximum value. So when you have a closed interval, you are going to have a absolute max and absolute min if your function is continuous in that interval. So what you do is, if you have a closed interval, the idea is a little different. You find your critical points, check if those critical points are in your interval, test all your endpoints and your critical points in your function, in your original function. You're plugging it into your original to find out your y value. Okay, your original gives you your y value. These give you points on the curve, and the highest is your absolute max and the lowest is your absolute min. And if they ask you for the value, they're asking you for the y value.